Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to area and distances. We are going to go ahead and do this from a calculus standpoint because we are now moving into areas that are not necessarily of basic shapes. So finding the area under a curve. So here we go. So let's say you have some kind of curve and you want to know the area from A to B, and you want the area under this curve. Well, at this time we cannot get a perfect area, but what we can do is we can go ahead and make rectangles. Okay, so here I'm going to go ahead and I'm going to turn this into 4 rectangles. So okay, so I've taken that section that was, we can go, well, however far apart B minus A is, and I split it into 4. And that's how wide each of these are, because I did Y4 because there were 4 rectangles. So that's going to be our, technically we call that our change in X, right? Our delta X. So keep that in mind, that delta X is going to equal your B minus your A divided by how many ever rectangles you make. Okay, you might make more rectangles. Now we have to decide, are we going to use the left side of each rectangle as the height or the right side? So let's say I choose left side. Okay, in the first two it kind of undersold it, but in the second two it kind of oversold it. So that's one way to do it. Okay, or could I have done right side? So over, 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 and over. Again, oversold, undersold. You could have even done the midpoint of each. Okay, let me erase those pencil marks. That got really streaky. So here's the middle, so we'll use this height. Here's the middle, so we'll use this height. Here's the middle, so we'll use this height. And here's the middle, so we'll use this height. And sometimes the midpoint is more accurate, but each of these has a height, correct? So let's say we're just using, we're starting with A, right? So we'd have our A plus however big delta X is, A plus 2 delta X's, and A plus 3 delta X's. We'd use 1, 2, 3, 4 rectangles, so we need 4, right? And so this would be f of A, this would be f of A plus delta X, this would be f of A plus 2 delta X, and this would be f of A plus 3 delta X, right? Now to find the area of the triangle, we take the width times the height, right? So delta X times our Y value. Well, we'd have delta X times this Y value plus delta X times this Y value plus delta X times this Y value plus delta X times Y value. Delta X Y2 plus delta X Y3 plus delta X Y4. Why multiply by delta X each time when we could do this? So instead of going, oh, base times height plus base times height plus base times height plus base times height, their bases are all the same. So we can just do height plus height plus height plus height and then multiply by the base. So that's kind of up to you. All right, so let's actually go ahead and look at an example. Okay. We are going to find the area under the curve using 8 rectangles. So I'm going to have n is 8 rectangles. And our f of x is going to be x squared plus 2. And our window is from 1 to 3. Okay. So parabola that's been shifted up 2. We only want the area from 1 to 3. Okay. Now let's think about that. We're starting at 1. We're ending at 3. What would be in the middle? 2. What would be in the middle of each? That'd be 1.5. That'd be 2.5. But that's only 1, 2, 3, 4 sections. So cut those all in half again. 1.25, 1.75, 2.25, 2.75. So now we have 1, 2, 3, 4, 5, 6, 7, 8 sections, right? And we know that the graph is doing this and taking off. That was not there. That was me writing the number 1. Okay, so I have my 8 rectangles drawn, my left sides, right? Okay, so this is probably going to be under, because every one of those rectangles were kind of under the curve. So the left-hand side is the short side for everything. So our first rectangle starts at 1. Our second rectangle starts at 1.25. And then 1.5, and then 2, and then 2.25. Whoops, I forgot 1.75. Then 2, 2 1/4, 250, and 275. That's our 1, 2, 3, 4, 5, 6, 7, 8 x values, right? Okay, now how did I get that 0.25? Well, b minus a divided by n. That's the other way you could have gotten it. Do you have to draw out the number line each time and split it up? No. Was it a great visual? Absolutely. Okay. Now, we could do the left-handed limit. Let's see. If you substitute, you'll get 3, 3.5625, 4 1/4. I might have these already written down. 5.0625, 6, 7.0625, 8.25, and 9.5625. Okay, so we could do 0.25 times 3, plus we could multiply these all by 0.25 and then add them together, or and we get 11.6875. Now, what if we did right hand? So we'd start at 1 1/4, because that's the right side of rectangle 1. And we stop at 3 because that's the right side of rectangle 8. So the only difference here is we don't include this 1, 3. Instead, though, we get this 3. When I substitute 3, I get out 11. So all these other numbers are going to 3.5625, 4.25, 5.0625, 6, 7.0625, 8.25, and 9.5625. Instead of typing it all in my calculator again, since I know the only thing that changed was at the beginning number should come off and an 11 should go at the end. I'm just going to, since I can add in any order, 13.6875. So the true area is probably somewhere in between it. By the way, the true area is 12.6 repeating. And I'll eventually get a video on how you can get that true area without doing this. But what happens if instead of the left side or the right side, we do the midpoints? Okay, this requires a little more work. So the middle of rectangle 1 is somewhere between 1 and 1.25. It's at 1.125. So that would be the middle of our first and the middle of our second. 1.875, 2.125, 2.375, 2.625, and 2.875 would be the middle of all 8 rectangles. And of course we need to get the y part of that, right? 3.265625, 3.890625, 4.640625, 5.515625, 7.640625, 8.890625. Did I miss one? That one was supposed to be here. I did. This was supposed to be 6.515625 and 7.640625, 8.890625, and 10.26565. That's a lot to write. So I know that my formula is x squared plus 2. But my width is still a quarter, right? So I still have my same width. And I'm just going to actually type them into the equation. 1.125 squared plus 2 plus 1.375 squared plus 2 plus 1.5625 squared plus 2 plus 1 is 1.625. This will say 1.875 squared plus 2 plus 2.125 squared plus 2 plus 2.375 squared plus 2 plus 2.625 squared plus 2 plus 2.875 squared plus 2. And that came out to be 12.65625, which happens to be the closest one to the true area. So if we made more rectangles, would we become even more accurate? Absolutely. And that's what we're going to be looking at as what happens when we get to infinite rectangles. Okay. In fact, that's going to really connect into my next video, but I just wanted this video on how do you find the area, and you're using the distance, the change in x to help you figure that out. But come back for my next video and you'll see what happens as we move towards infinite rectangles. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.